We are building a NetDevOps CI/CD pipeline from scratch. Instead of manually logging into a network device and typing CLI commands to add device configuration, you make your network change in a simple text file, you push it to Git, open a pull request, get it reviewed by a teammate, and click merge. Once this happens, automated pipelines will instantly pick up your change, validate the syntax, show you a dry run diff of what will change, and push the configuration directly to your live devices. For example, let's say we want to configure BGP on leaf 3. At this time, when we look at leaf 3, let's do show IP BGP summary. There are no BGP sessions on this device. Instead of entering into configuration mode, typing all of these commands manually directly on this device, what we would do is that we will edit this leaf3 file and add our change as code. So let's do that. So in our leaf3.yaml, we add our BGP change, neighbors to spine 1 and to spine 2. We save this change. Then let's check the status in Git. So it shows that we've made a change to our leaf3.yaml. Let's check what the change is. The change is that we added these BGP neighbors. Let's clear and stage our configuration. Then let us commit the configuration. Now that we've committed the configuration, we can push to Git. When we push to Git, we get a link to create our pull request. What we can also do is that we can come to Git, pull request, we compare and pull request. We have leaf3 BGP peers. We can see the change that we are making. Then we will create our pull request. Once this is created, even before a human looks at this PR to review, we have some pre-checks being done that tells us exactly what it is that would end up changing on our device, including other checks of whether we can reach our device, management is up, and all of that. Also, your teammate can review this file by looking at exactly the changes you are making and submit their review. So let's wait for our checks to be completed. Our checks are completed. Before this is merged, we can look at the changes that would end up making to our device. Right here, this corresponds to the change we made and the pull request that we created. Now that we are convinced that this is sane, we can merge our pull request. The pull request in our CI/CD pipeline equates deploying this configuration directly to our device. So we would wait for this to run. It would take just a couple of seconds. Then we'd go back to our device and check whether we have BGP neighbors configured on leaf 3. Good. So our pull request has been merged. Now, let's go back. It took like 54 seconds. Now let's go back to our leaf 3 device and repeat the show IP BGP summary command. Now we see that we have spine 1 and spine 2 BGP sessions, those configured. The session to spine 1 is up, that means established, whereas the session to spine 2 It's not. This is simply because in spine 1, we've configured all the BGP sessions to our 4 leaves, whereas in spine 2, we have the sessions configured to just leave 1 and leave 2, and not leave 3 and leave 4. That is why we see this in the connect state. Now, if you don't have an idea on how any of these things work, don't worry, this is exactly for you. Because we are building all of this from scratch in a beginner-friendly way using free open source tools throughout. So, for example, if you have no idea how all of these actions, pull requests, that is fine. There is no expectation that you do know how this works because we are taking this step by step from scratch. So now let us look at the stack that would use to build our NetDevOps CI/CD pipeline. We will need devices that would push configurations too. So we'd create an Arista COS fabric with Container Lab. That will be our lab fabric. This will have just bootstrapped configuration that allows us to have management access to these devices. Just that. Then we'll have our automation engine as Ansible and Ginger. This is what we'd use to render our configuration changes and push those changes over Arista EAPI. Then would have GitHub and GitHub Actions, GitHub for hosting our code and the actions for managing the pull requests and running our automated CI/CD pipeline workflows. Essentially, as far as our pipeline is concerned, that would be our source of truth, right? We would push everything to GitHub. Then the last component in our stack would be our GitHub self-hosted runner, which will be a tiny background program that will run on our local lab machine. Now, this would act as a secure bridge that will listen for events on GitHub and then execute our Ansible scripts locally to configure our switches, our devices. All the code that would use in this build will be public on GitHub. So you have access to it and you are able to practice right alongside me. Now let's look at how we are approaching this entire build. In keeping with this being beginner friendly, we are taking this step by step instead of overwhelming you all at once. We'll break the entire build into small, focused episodes. That way, you can kind of master each piece before moving to the next. So, first, we will build our network topology and add bootstrap configuration. Okay? We will spin our container lab topology, which will have our 2 spines and 4 leaf, and this will have basic management access. That is all that we would add in terms of configuration to these devices. Next, we'll look at how to organize our network configuration variables. So we call this our data modeling. So for example, how will our project structure look like? We'll have inventory, we'll have playbooks, we'll have template. So under inventory, we'll have group variables and host variables. Under group variables, we'll have variables that apply to all our 6 devices. We'll have variables that apply to just our leaves. We'll have variables that apply to our spines. And under the host variables, we'll have device-specific variables. Then we'll have our playbook directory, which will contain our Ansible playbooks. Then we'll have our template directory, which will have our Ginger file or Ginger template. This part is very important because once you're able to conceptualize how all of these pieces fit together, you've made good progress in understanding how we are building this CI/CD pipeline, how we would generate configurations based on these, and how we would render the configurations for deployment. Once we are done with this, we would come to the Ansible automation engine part. This is where we'll write our Ansible playbooks to test and deploy configurations directly from our local terminal. Now, if we use, let's say, a car as an analogy, the Ansible engine is the engine in the car. You can't start the car without the engine. So the logic here is that even before we get into GitHub Actions, and all of that, we want to ensure that the engine works and that we can interact with our devices from our Ansible automation engine. All of these will be done locally. Now, GitHub Actions, in that same analogy, you can think of them as the driver. They decide, okay, when do we start the engine? But the engine must exist first. So we'll look at the Ansible automation engine, test and deploy locally. Once we are fine with that, then we look at how to connect GitHub to our lab. So we'll set up our GitHub repo, we'll install a local self-hosted runner so GitHub can communicate securely with our lab. Once we have all of these done, we have our lab fabric, we have our project structure, data model right, we have our automation engine, we have our GitHub stuff, our driver. We can now really move and get into action. So we'll automate our deployment and see this right in action. We'll build our GitHub Actions pipeline step by step, push a real network change like we saw, adding a BGP peer, preview the live configuration diff on a pull request, and deploy it to our switch upon merging. Step by step, and we'll go through this entire build. So by the end of this series, you will have a fully functioning CI/CD pipeline that you can showcase in your portfolio. And if you are excited about this, kindly like this video and subscribe to the YouTube channel. Thank you.